All right, my friends, today we are going to look at some physics felonies. These are some horrible things that intro physics students say that drive their physics teachers absolutely nuts. So, number one on the list, the king, is saying this: I thought G was negative 9.8. This is especially demoralizing when this happens toward the end of a unit. Let's take a look at this one. Well, so to fix this, first of all, let's just please stop saying I thought G was negative 9.8. Let's look at an example here. So a ball's thrown downward at 6 meters per second from a 50-meter high cliff. When does it hit the ground? So we will choose a positive direction to be up, all right? Say we did that. In that case, we might go ahead and use this kinematic equation. And you notice the acceleration A. Now this is key. Since we've chosen positive up, the acceleration due to gravity is going to be downward, so we're going to say it's minus g, or minus 10 for the AP students. And if you want to use negative 9.8 to avoid that little 2% error, you're more than welcome to. Well, so now if we plug in these quantities into that equation, so delta y is negative 50. Now why is that? Because positive was up and the thing went down. So the final position was lower than the initial position. So delta y is negative 50. The acceleration due to gravity is negative 10 or negative 9.8 if you must. And the initial velocity, v naught, is negative 6 because we threw it downward. And so when you solve that baby with either a calculator, quadratic formula, your favorite method, you'll get 2.62 seconds. Now we could have worked the same problem by choosing the positive direction down. And we could have used the same kinematic equation. The only difference here is the acceleration due to gravity being in the downward direction, which is now positive, would just be equal to g, or 10, or again 9.8 if you must. And so then the only thing that would really change here then are the signs of delta y. It'd be positive 50 because the final position would be like more positive than the initial position. The acceleration due to gravity would be positive 10, or just g, and the initial velocity would be positive because we threw it downward. You'll get the same answer. So my friends, please just use g is 9.8 or 10, and let your choice of positive or negative directions let you decide whether the acceleration due to gravity is going to be plus g or minus g. The next felony is saying this: it hit the ground, so v final equals 0, right? Let's take a look at this. So first of all, please, when working these situations, stop saying it hit the ground, so v final equals 0. Usually this is coming up in kinematics problems and you're talking about the flight of something. Often right before it hit the ground, that's very likely when it's going the fastest, depending on what the problem was. And so typically you're talking about the velocity right before impact, which is not going to be 0. It'll be 0 after it bounces around and comes to a stop or something. But right before the impact, it's not going to be 0. So let's take a look at this. It says a ball's thrown downward at 20 meters per second. From a 50-meter high cliff, pretty similar to the last problem actually. At what velocity will it hit the ground? So say we chose positive up, and we're going to use this kinematic equation to figure out the final velocity. Now here's the key. The final velocity, we're not going to say that it's 0 just because it hit the ground. We're going to figure out how fast it's going right before it hit the ground. Your initial speed or initial velocity is going to be negative 20 because if we chose positive up, and you threw it downward, so the initial velocity is negative 20. And your acceleration is going to be negative 10 or negative g. And then you could solve this, and what you'll find is you'd get one of those situations where v final is plus or minus a number, and you'll choose the minus because you know that right at the impact it's going downward, or it's going in your negative direction. And so if you choose positive down, then your acceleration due to gravity would be 10. Your initial velocity would be positive 20. And again, going through the algebra, you would get a situation where you had VF is either plus or minus 37.4, but you would choose the positive answer in this case because, again, the thing is going downward, and you chose the positive direction down. But moral of the story here is don't say the final velocity is 0 just because it hit the ground. When you're doing kinematics, you're talking about the flight. Third physics felony is saying the force of the acceleration. Kids like to do this, and this will again drive your teacher nuts. So the way to fix this is, first of all, please stop saying the force of the acceleration. That's just jumbling words together. That's like saying the momentum of the friction of the energy of it all. It's just nonsense. But let's see why this might come about. So here's a scenario: person's on an elevator that accelerates upward. Draw the forces on the person. So let's do this. Here's the person on the elevator. One force would be mg, the weight downward. Another force would be the floor pushing up on the person. That would be the normal force. So far, so good. And here's where it starts to go awry. Then kids will go, wait a minute. There's also the cringe, the force of the acceleration. Um, Please don't do that. No, don't do that. Um, what you want to do instead is go, what forces are on this person? Well, the earth pulls down on them with their weight, so mg is down, and the floor of the elevator pushes this person up. Um, but the deal is, it just pushes up with a greater magnitude than mg pulls down, and that is why the person accelerates upward. So there's no need to invoke this magic force of the acceleration. You just have these two forces, normal force and mg. That way, when you go to use F equals ma, you can see more of the cause-effect relationship. The forces are n up and mg down, and the fact that n is bigger than mg causes the upward acceleration. You don't add on the left side some magic force of the acceleration. All right. So punchline here is, the person accelerates upward because the normal force from the floor pushing upward is just larger than the weight mg. Now, to be fair here, there is a technique using, it's called going into a different reference frame, where it is possible, once somebody has gotten a little bit further in their studies, where you can do such things like invoking this extra kind of force like this. It's just a bad idea when you're first starting. So just stay in the lab frame and just think of the normal force being larger than mg, and it's a recipe for success, my friends. So the very last physics felony I want to mention is saying, well, there's in a problem there's tension, there's gravity, and the centripetal force. Let's talk about why this is a problem. So first of all, please stop saying that there's tension and gravity and the centripetal force. Let's look at a scenario. Car drives around a bank turn. Draw forces on the car if the car drives at the maximum speed. I guess the maximum speed for not like skidding out of the turn. So here's this car on this bank turn. And the forces that would act on this car would be the earth pulling down, mg, the normal force, the force perpendicular to the road surface, pushing kind of up, diagonally upward, and then the friction force that's also helping to kind of turn this car along parallel to the surface of the road, and sort of down the ramp this way. If they're driving at the very fastest they could go to make it, the friction force is helping you to stay in that turn. Well, so here's the key. The centripetal forces, the horizontal component of the normal force, meaning the leftward aspect of the normal force, and the leftward aspect of friction, those are the centripetal forces. So you don't say there's like the normal force, friction, mg, and a centripetal force. The horizontal parts of normal force and friction are what is causing the turning. So they are the centripetal force. There's no extra magical centripetal force that we draw in the picture. Centripetal force is just a catch-all name for any force that happens to cause turning. So in general, it's not going to be by itself as a centripetal force in your picture. It's going to be a real live force that you drew, or at least a component of it. So to summarize, these are the physics felonies. Don't clown yourself by committing any of these things, and don't drive your teacher bananas. Hope you enjoyed this and hope you find it helpful, and don't do these things.